So we're looking at a number of questions, and what we'll find is that all of these questions are quadratic in nature. So we're going to have to try to develop some sort of a quadratic equation and try to solve it that way. All right, so here comes your first question. It says that a movie theater can accommodate 400 customers, 400 moviegoers, and right now they're charging them $5 per day. And what the owners are trying to do is to see if they can perhaps earn more money. Right now, if you think of $5 and 400 people paying $5, that's going to be $2,000 worth of revenue, 5 times 400. So they're looking to see whether they can do better than $2,000 by looking at various pricing models. So let's look at this table first of all, and I'm going to point out to you exactly what the current situation is, and then we're going to look at some alternatives. So right now we're at $5 for 400 people, but they're thinking that if they were to increase their price, that every time they increase their price, they're going to get more money from each ticket, even though they understand that when you increase your prices, then you're going to lose some customers. And they estimate that they'll lose about 25 customers every time they increase the price by 50 cents. And they're willing to try that out to see how that works. So, for instance, if they went to $6, that means that they've raised that twice. They've raised it by 50 cents twice. So they're going to lose 25 customers each time, which means they're losing 50 customers in all. So if you think about it, that means that the $6 ticket price will only pull in 350 customers. But if you multiply those two figures together, you're actually looking at $2,100 as your revenue. So they're doing better, even though they're losing customers. The fact that the price of the ticket has gone up means that they're getting more for each ticket. So when they saw that, they said, okay, why don't we raise the price even more and try to get more money from it? So they raised their price up to $10. But let's look at the impact on their customers. And if you think about what $10 means, it means that you've added on $5 onto your price. So you put on 10.50 cents onto your price. 10.50 cents is the $5. So every time you raise by 50 cents, you lost 25 customers. So it means that you have 10 times 25 customers that are no longer coming to you. So of the 400 customers that you used to have, 250 no longer come to you. So now you're down to 150 customers. When you multiply those two figures together, you're looking at $1,500, which means you're now less than where you started off at. You were able to go up to $2,100 when you raised the price to $6, but raising it up to $10 now means that your revenue is down to $1,500. You can actually look at it another way. What if you were to lower your price? For instance, what if your price was $4? Now, remember, raising your price meant you had less customers. So lowering your price should actually mean you have more customers. So if you dropped your price down from $5 down to $4, it means that you dropped it by 2.50-cent decreases. So you should gain 2 times 25 customers compared to what you were before. You used to have 400 customers. You should now have 450 customers. When you multiply that by the $4 ticket price, it actually only comes to $1,800. So you're still not better off than where you started off at $2,000. So we might have to look at a more organized and structured way to figure out exactly what price they should charge. Well, let's start by putting a let statement together. We're going to let X equal the number of these 50-cent price increases. From that, we're going to develop a price equation, and we're going to develop a number of customers equation. The price equation, remember, you started off at $5, and every time you raised your price, you added 50 cents to it. So here's your price equation. $5 is the starting point, plus 0.5 times the number of these 50-cent increases. So for instance, X was equal to 2, it means you've raised your price to $6 because you've put 2 50-cent increases on it. So that really is like the $6 price that we talked about before. Your number of customers now is going the other way. So as your price goes up, your number of customers goes down. You're losing $25 every time you change this X by 1. So you change it by 50 cents, you lose 25. You change it by $1, which means 2 50 cents, it means you're losing 50 people, and so on. So that's why this is the number of customers equation, and that's why this is the price equation. Now, if we're looking at revenue, Revenue is the product of those two. Every time we wanted to know the revenue, like for instance, the $1,800 revenue, we multiplied the $4 times the 450 customers and we got $1,800. It's the same thing when we're doing it algebraically. Your revenue is your price times the number of customers. Now let's put that with the x's in it. That means that your revenue is the customer equation, which is the 400 minus 25x multiplied by the price equation, 5 plus 0.5x. If you think about it, this is actually a quadratic equation because we're multiplying these two brackets together. And when you multiply them together, this x here times this x here is going to give you an x squared. So we know it's a quadratic relation that we're dealing with here. So what we need to do now is to see if we can figure out where the maximum is of this revenue, this quadratic equation. And since it's in factored form, we can find the zeros. And if we find those zeros, then we can use the midpoint to figure out where the maximum is, because that midpoint is our axis of symmetry. Remember the axis of symmetry? So let's find those zeros. We're going to take the quadratic equation, set it equal to 0, and then we're going to take each side of that and set that equal to 0 to find the 0. So we have 400 minus 25x equal to 0 here, and we're going to solve this by setting the 400 to the 25x. We're just simply moving the minus 25x over to the other side and making it positive 25, and we solve for x, so x is equal to 16. On the other side, we're going to do the same thing. We're going to take this equation and set it equal to 0. So here it is. 5 plus 0.5x is equal to 0, and we're going to solve this one as well. We're going to move that 0.5x to the other side and make it negative, and then we solve for x. It works out to be minus 10. So what do we do with these two zeros? Remember, in between the two zeros, when we add them together and divide by 2, we're going to get our axis of symmetry. That's where our maximum point is. So let's do that. We're going to add 16 plus minus 10 and divide that by 2. 16 plus minus 10 is 6. 6 divided by 2 is 3. So 3 is the x that's going to give us our maximum. So let's use x as the midpoint of our equation, and here's what the result is in the two equations that we have. We have the price equation giving us, with that 3, 5 plus 0.5 times 3 is $6.50. That is going to be the price that's going to give you your maximum revenue. And if we put that same 3 into the number of customers, we're going to get that 325 customers is what you'll have if you were to make your price $6.50. So what's your revenue? Your revenue is going to be that 325 times that 6.5, or $2,112.50. You can't get any better than that under the current circumstances. So we now have our answer. We're going to charge a price of $6.50, and we're going to get a maximum revenue of $2,112.50. So here's your answer right there. Nicely stated and very clear. Let's move on. This one says we have a bridge over a river, and it's supported by a parabolic arch which is 20 meters in width at water level. So in between the two ends of the bridge you have a 20-meter distance, and it says that the bridge gets up to 12 meters. The maximum height of the arch is 12 meters. We're going to be having to figure out also whether we can put a barge through that opening in the bridge, which is 10 meters in width and 8 meters high. That's what we need to figure out. But the first thing we need to figure out is, what are we dealing with here? Here's a diagram that helps us out. It shows us that if we position it this way, and it's not the only way to position it, but it's probably easiest to do it this way, where one end of the bridge is at the origin right here. That's the left end of the bridge. And then the right end of the bridge is at 20, 0. This is like the surface of the water. The x-axis is like the surface of the water. So between the left edge and the right edge of the bridge, you have a 20-meter distance between those two. At the very center of this parabolic arch will be the top highest point of the bridge, which they told us was 12 meters. So right here is a 12-meter mark. If you look across at the y-axis, you see that the bridge gets up to 12 meters high. So left edge at 0, 0, right edge at 20, 0, and the top of the bridge is right in the center between those two zeros. And you can probably guess what that is. in terms of the x value, I'm pointing to it, it's actually 10. That makes sense. At 10, 12 is where you have your vertex right there, in between the two zeros. Okay, so let's create an equation for this bridge using the stuff that we've learned before about vertex form. We have the vertex, we know, is in between the two zeros, so it's between 0 and 20, which can easily be done. We saw it on the graph before. It's at 10. So we have the value of the vertex as being 10, 12. 10 is the x value at the vertex, and y is the 12 at the vertex. All right? Now we need to get our a. So let's put it in vertex form. Looks like that. Y equals a, x minus 10. The 10, remember, is x value at the vertex, and 12 is the y value at the vertex. And we have one value that we can put in. We have several values, but we know two values that we can actually put in, and those are the zeros. If it's in vertex form, it's okay to use the zeros to get what the value of a is. We know that the origin is on our graph. We saw that. So let's put in 0 for x and 0 for y. So there we go. And if you continue solving that, you're going to get 0 minus 10 squared, which of course is just minus 10, and that's 100. So let's put that 12 that we have here on the left hand side and make it negative. So 100a equals minus 12, and therefore a is equal to minus 12 over 100. And if we simplify that, it works out to be minus 3 over 25. So we have our a. There's our equation. Y equals minus 3 over 25, x minus 10 all squared plus 12. Okay, let's use that now to figure out whether this barge that we talk about can actually go through this tunnel. Now remember, we need 5 meters on the other side of the axis of symmetry. Axis of symmetry is that line in the center, which was at 10. X equals 10 is the axis of symmetry. So I want us to take that and add 5 to it on one side and subtract 5 on the other to give us that distance of 10 meters that we need for this barge. So we're going to take 10 and minus 5 and 10 plus 5 to give us 5 and 15. So when x is 5 and when x is 15 is the beginning and the end of that 10 meter distance that we need to make this barge go through. So we're going to take that now, we're going to plug in one of those. I'm going to use the 15. All right, so we're using the 15 rather than the 5. We're going to use the 5, but let's use the 15. So we're putting in an x value of 15, which is one edge of where the barge needs to go through. And we're going to get 15 minus 10 squared, and then we're going to multiply that by minus 3 over 25 and then add 12. So we go through the process. The 15 minus 10 gives us 25. This 25 actually cancels out with that 25, going to leave us with minus 3, and minus 3 plus 12 is 9. Here's what this is telling us, that at that edge, which is 5 meters away from the center at 10, so we're at 15, the height that we need, the y value that we need, is 9. But the barge is only 8 meters tall. So it means that because the barge needs 8 meters and the bridge is actually 9 meters high, it means that the barge can actually fit. So the bridge has a height of 9 when the width is 10. Since the barge only requires 8, it can pass under the bridge. So we're good to go. Last question. Nursery school. They want to build a fence around a playground in the back. And they are going to use 600 meters of fencing. But because the playground is going to be right up against the wall, they don't need to put any fence along the walls. They only really need 3 sides for this playground. Here's what that looks like. So we have the wall along the back of the playground. We have this side, the 2 widths of the playground, and then the length of the playground that represents the 600 meters. So we can actually set up a little equation that says that x plus x, so this x plus this x plus this y, when you add them all together, it gives you 600. Okay? Now, why don't we simplify that? We know that we can put like terms together. These 2 x's together means you have 2x plus the y to equal 600. And then, why don't we rearrange that so that we isolate the y? So we now have, instead of 2x plus y equals 600, we have y is equal to 600 minus 2x. And the reason we're doing that is because we can redraw the playground with some new dimensions. Look at what I just did. I took away the y that was there, and in its place I'm going to put 600 minus 2x. And that makes sense because over here we said that y was equal to 600 minus 2x. So it's okay for us to remove that y and put in its place something which is the same as y, which is 600 minus 2x. So over here is exactly what this diagram used to be. Where we used to have the y, we have 600 minus 2x because we know that y is 600 minus 2x over here. So here's our new playground. It's the same playground, just with a different length, which we now put in terms of x. Well, how do we get area? We get area by using the formula length times width. So if A represents the area, why don't we do this? Why don't we say that area is equal to this width, which is x, times this length, which is 600 minus 2x, and there is your formula. And I think you're beginning to see why this falls into the whole quadratic thing, because when you multiply this x into, or distribute this x into the bracket, you know you're going to get an x squared term. So let's look now at how we can get the zeros of this quadratic, because we know that if we can get the zeros, then we can figure out where the maximum is. We're trying to get the maximum area. Let's take this formula and set it equal to 0. Take each side and set that equal to 0. So we're taking this and setting them both individually to 0. Well, this part is being set to 0. And we do the same thing on the other side. We're going to take this part and set it equal to 0. So 600 minus 2x is also equal to 0. And we need to solve for x. But guess what? This is already solved because this already has x by itself and it says that x is equal to 0. So one of the zeros is x equals 0. We only need to solve this side. When we solve this by putting the minus 2x as positive 2x on the other side, we have that 2x equals 600, and therefore x is 300. So now we have our two zeros. Let's take those two zeros and find the midpoint so that we can figure out where the maximum is. So we add the 0 plus the 300, divide that by 2. That of course gives us 150. So now we know where our maximum is. Our maximum is on that 150 when x is the width is 150. When x is 150, the area would be 150, here's your x, 150, times 600 minus 2 times 150. That's going to give us our area, our maximum area. Okay, because we use 150 since that was where we knew the maximum was. When we do the math, it works out to 45,000. So we can now come up with our answer. And the maximum area that we can enclose is 45,000 square meters. And that's all she wrote.